Hi, everybody. Good morning, good afternoon, good evening. Welcome to today's webinar on achieving greater operational efficiency for VMs and containers. My name is Janet. I'm going to be your host for this session today. Before we dive in, I wanted to take a couple minutes to go over just a few housekeeping items. We will have live Q&A at the end of the webinar, so be sure to drop your questions in the Q&A chat box on the webinar platform. Just feel free to ask your questions throughout, and we will answer as many of them as we can live at the end. There will also be an on-demand version of this webinar that will be available after its conclusion, as well as a couple pieces of collateral if you'd like to learn more. So again, my name is Janet, and I am a product marketing manager here at Portworx. I'm joined today by Prashant, who is our director of product management, and also Niranjan, who is our principal product manager. As far as what we're going to be going over today, I'm going to kick things off with an introduction to Portworx. Then I will pass it off to Prashant, who will talk about how to run Kubevirt on Portworx. And then Niranjan will talk a little bit about protecting your Kubevirt applications. And then again, at the end, we're going to have open Q&A. So please feel free to drop those questions in throughout. So just to introduce Portworx to those of you who might not know who we are a Kubernetes data platform that provides storage, data protection, and database services that are going to simplify your Kubernetes environment. So we're able to provide reliable, persistent storage, backup and recovery, as well as disaster recovery for those mission-critical applications that you're running on Kubernetes. Portworx is a highly flexible solution that works in any environment, whether that's public cloud, private cloud, or hybrid, and really works with any Kubernetes distribution. When we talk about the tangible business benefits that customers are able to achieve using Portworx, you can see a couple of them on the screen right here. We've been able to reduce the time it takes to deploy applications from 6 months down to just a few hours. We've also had customers who've been able to achieve zero RPO and no data loss for those mission critical applications. And we've also had customers who've really been able to reduce their actual infrastructure and storage costs using us. One final thing that I wanted to touch on was IDC naming Pure Storage a leader in container data management. This is a brand new category for them and really shows the momentum that Kubernetes and container data management are really starting to have in the IT space. So we're really excited about this new designation. They've claimed that Portworx is one of the data platform for running your mission critical applications. So again, you can check that out on our website if you want to learn more. And now I'll pass things off to Prashant.
Thanks, Janet. This is Prashant Rathi. I'll be talking to you about how we are going to be able to run modern applications, be it with VM-based now, on Portworx as the container storage platform. So as we've seen over the years, the infrastructure stack has been evolving. Talking to the customers for a long time around, hey, how are we going to run container applications? And should we be running them on virtual machines? Should we be running them on bare metal instances? Customers have made choices based on their environment, which has a lot of VM-based deployments. They've chosen to run on virtual machines with Kubernetes and then Portworx. In some cases, they've gone straight to bare metal, and they wanted to run their infrastructure from day one on bare metal. Maybe it's for performance reasons, maybe it's for just simplicity. What we are seeing now evolve is, as we have been talking to customers, and customers are looking at options to run some of their brownfield applications along with their greenfield applications, which are already on containers. They're trying to think of various ways to merge the two environments. One of the examples there and in the new stack you can see there is that underneath, customers are trying to simplify it, right? So bare metal becomes your sort of chosen instance types, and then on top of that, for performance, to match the performance, they want to run fast storage. In order to combine that and provide the scale and resiliency that is required for Kubernetes-based environment, they're choosing a scale-out storage like Portworx. They're running that with Kubernetes, And alongside the container, you can see on the right, there is virtual machines. Now, what are virtual machines doing on top of the container environment? And that's what we are going to discuss at length today. But bear in mind, this is becoming more and more common with customers trying to simplify at least the running everything in a simpler environment and a modern stack, and now bringing in those virtual machine applications. And let's dive into some of the reasons why they might be doing that. So first and foremost, a lot of customer apps are still running on virtual machines, and they will be running for virtual machines for various reasons. Is it possible to migrate? Yes. Now the answer is yes. In the last year or two, where we've seen a tool set which we'll be talking about, which allows customers to migrate their VM-based applications from whatever ESXi environment they must be running on, based on VMware, be on OpenStack, wherever they are running it, they want to bring it into Kubernetes, and there are possibilities in doing that. Why would they be doing that? Another reason is organizations can now choose to decide when they want to containerize certain applications. They can continue to develop their new application on containers, but with this option, it allows them to sort of not having to do that for all of their stack. They can decide some applications may take longer, some may be ready sooner, but they can bring those all together by making VMs run on Kubernetes. And finally, like any platform, there is a value in unifying management, reducing the overhead, and just simplifying operational complexity. And with this option, they can do that. They can run all the VM applications along with their container applications side by side in a single environment, which is infrastructure agnostic, cloud agnostic, and gives them the best of both worlds. So that's sort of what we are seeing evolve, and we'll discuss at length now how that is going to happen and what is enabling that. So all of you have seen the Kubernetes environment, where Portworx plays in. Portworx is the sort of scale out storage for container granular applications. Our goal has been from day one to make make storage for Kubernetes developer ready. With what that we mean is that the storage should run as close to the applications as possible, so that as applications scale, the storage itself can scale. It can do all the things with the application workflow in mind. Think about high availability, think about disaster recovery, think about even security or automated operations. All of that should be done with applications in mind. The best way to do that is making sure that your storage and your volumes, in case of Portworx, are all granular to that app level app designation. Now, you can see at the top there, we've been running container applications, multiple of them at scale. Portworx can scale out, so you can run thousands of nodes on a Kubernetes cluster. Now, when we bring in VMs there, then the VMs require a layer of storage on top or to provide for the VM volume, boot volumes and VM data storage. It requires same kind of resiliency that I'm talking about for container applications. Now with Kubevirt, over the last few years, it's gone on and it's grown a lot, and it's become a very big part of Kubernetes deployments across platforms. Now Kubevirt is a solution for making VMs run on Kubernetes. Now OpenShift supports that with their OpenShift virtualization. We have other Kubernetes distributions also providing support for it. And what Kubevirt is doing is running agents and controllers like any other Kubernetes Kubernetes-based deployment would have. It's allowing you to make that part of the Kubernetes orchestration layer. So we can run with something called libvirt, which runs as the package with Kubevirt, and VMs can now be deployed on Kubernetes environments. With this, they require storage. And with storage, they require a few important characteristics. They require high availability, so that for the VMs to be available if there are failures in the deployment. There is live migration, which we'll talk about in detail. And eventually, customers also want to make sure that all the tenets that they have around disaster recovery and business continuity apply to those VM-based applications. Otherwise, there won't be any, there will be a gap in terms of functionality between what they can do with containers and what they can do with VMs. So Portworx, together with Portworx Enterprise and Portworx Backup, the Portworx platform provides and fills the need both for storage management and for data protection. First of all, I'll talk about how we play a role in storage management. What are the key use cases with Portworx Enterprise? And then we'll dive deeper into data protection. So first and foremost, high availability of VMs. This is table stakes, VMs, VMware in its own stack with vSphere and vCenter and all of the tools that VMware provided. This was a given, right? Even if a VM is running on a node and the node is dies at an availability zone, in this case, I'm showing it in a cloud scenario. If the availability zone is not available, then the VM needs to be moved to another zone, and the functionality should not be hurt at all. So Portworx supports that, like it would do for any Kubernetes application when the pod gets rescheduled on another, or when there is a rack failure, or even in some cases a whole availability across or the failure zone is in AZ. It will do that for pods. Similarly, VM is here a pod in Kubernetes, and that pod can be now rescheduled to another node in that another zone. Portworx uses a concept of read-write-many volume for supporting this particular for supporting the VM deployments. Now, Portworx by itself is a distributed storage, so we will make sure the VM replicas are available, or the storage replicas are available for that VM in that availability zone. And along with our scheduling mechanism and algorithms, we will make sure that the VM gets scheduled on that new node or the new zone where the storage is already available, resulting in zero disruption and high availability in case of worker node failures. Now, in this case, we'll talk about why we use a shared v4 volume or an NFS volume in a minute. But this scenario applies both for read-write-many or even our regular volumes. In case of a regular Portworx deployment, we use specifically for VMs, we'll use shared v4 or our read-write-many volumes. With that, to the next point, we'll talk about why read-write-many. So live migration is the second important requirement from customers. Often there are situations where customers want to live migrate VMs between those Kubernetes worker nodes. In those situations, there should be zero disruption to the actual VM. The VM should not be, anything running on the VM should not be affected when this live migration is happening. In order to do that, you have to have your storage attached to both the nodes, one where the VM is migrating from and the one where the VM is going to migrating to. And in that case, when you want two separate pods connected for some time at least on to the same volume, you want to use a shared v4 volume. And with libvirt, it exposes us a library which allows us to use Portworx shared v4 volume, which are driven by NFS, to the VMs, and then we are able to do that live migration, and we'll demonstrate that here quickly. But that allows us to do this live migration without affecting any disruption to the application or the VM itself. The volume will be the way the volume will do the mount. Everything will be abstracted away in a way that there is no implication on performance. The resiliency is still there, and Portworx will maximize performance it can get using this particular driver. So that's sort of the main use case or a new workflow that we have with live migration. This is being used by customers running Portworx on OpenShift virtualization, and this becomes a key part of this whole workflow with VMs and Kubevirt running on Kubernetes. The next two things are around disaster recovery. Now, as I said before, VMs in this world are nothing but pods on the Kubernetes cluster. You have your source cluster on the left where everything is running fine. One fine day, there is an outage on the data center, and you want to have an alternative environment ready. That's where Portworx disaster recovery comes in. Now, async disaster recovery is when your VMs have to be moved across two data centers or two cloud regions where you want to that RPO, RTO, SLAs that you have. With async DR, you can get up to 15 minutes of RTO and 15 minutes of RTO and fast RPO, and that allows you to move those pods along with everything else on your cluster. So we are treated like any other object, along with the configuration data, along with your egress controllers and everything else. Everything gets moved to the destination cluster, and there is no disruption in your operations. So this is a sort of, I would say, the benefit of just having disaster recovery in place and making sure that everything is integrated into the same control plane that you are operating all of your environment in. The second way to do this is using sync disaster recovery. If your RPO is 0 and you're running a stretched Portworx environment across your 2 data centers that you do today for your container applications, similarly, your VM pods will also be using the same DR mechanism, same DR scheduling, to make sure that when there is a failover, we will detect that failover and we will move your pods along with the data onto the other failure domain. And this is done with, as I said, with using replication on the Portworx storage side. Similar to other container applications, this will give you a 0 RPO performance, and this is the best solution if you want to make your SLAs are that stringent. So those are the 4 use cases we spoke about: high availability, live migration, async and sync disaster recovery. And these are all available today with the Portworx Enterprise solution, both for VMs as well as along with the container applications that are running. This is now supported for your VMs running Kubevirt on any cluster or any Kubernetes distribution that supports Kubevirt. We'll take a quick pause here and we'll go into a demo. And with that, we will show you how that works. As you can see, I'm using Kubernetes, OpenShift environment, and we have a VM setup here. We are going to show how that VM was set up using a vSphere console. We are going to write some data into that VM just to ensure that when we are doing all of this migration and we're bringing that VM into the Kubernetes environment and then running through some use cases, there is the same data exists. So we've written some file into the VM. Now we are in the OpenShift console, and you can see there are 3 main components to this. There are 3 operators in this console. One operator which is going to allow us to migrate the VM, bring it from the vSphere into the OpenShift environment. So OpenShift offers MTV, which is a tool based on Forklift. Then there is the OpenShift virtualization operator, and then there is Portworx Enterprise, which will the operator which will allow the Portworx lifecycle management. Now, we are going to use a namespace specifically for the virtual machines. So this is the VM's namespace, and we are going to import our, this is where we will bring in, this will be the target namespace when we import the VMs into OpenShift. So you can see that there are the providers, both for the vSphere provider and we have the OpenShift provider. And now we will start the process to migrate from the vSphere provider to the OpenShift provider. This process requires some network map, storage map configs. I've skipped that here just to for the purpose of saving time. And we've started the migration process. This is all done through the OpenShift toolset. Underneath, the storage class has been configured to use a Portworx storage class. And you can see that as the VM will get migrated, we can log in. And when it's ready, we can see if that file still exists. And the storage class there you can see is the PVC is based on a shared read-write many volume that comes from Portworx. And as the migration completes, we will go in and check whether the VM has successfully migrated into the OpenShift environment, into the target namespace that we have designated for that VM. The forklift tool allows you to do this, and this is all integrated as part of the console. We'll give it a minute here. When all of the data you can see is getting copied over and all of the configs are in place, we now go in and that same VM will make sure that is available in the OpenShift console. We'll quickly log in and check whether that VM is ready. It says it's ready, and that's where the VM is. Just want to quickly make sure that the file that we wrote to on that VM, we can log and we can check that and make sure the VM is migrated as is. Okay, once we do that, the next step here is to show you how to do a live migration of VM between nodes. You can see we are on a worker node 2, and we're going to move that to a different worker node. And there's an option right in the OpenShift console. We'll click and do a migration. And while this migration is happening and the migration process is running, we'll go in and log in into that VM and make sure that we are still able while the live migration is happening, there's no disruption to that VM. So we are into the VM console. We are able to log in. We are able to check that the file exists. We've just written a date command there, and that basically shows us that even during migration, the access to the VM is not lost. This again supported by the same storage volume under Portworx. Now, the second thing we'll do is high availability. In order to simulate high availability, we need to do what we would do in a typical Kubernetes environment. We'll cordon off a node, and we will then delete the pod. So we've cordoned off a specific worker node, and we are going to now delete it so that Kubernetes will schedule that VM onto another worker node. And we have to ensure that while Kubernetes is doing that, the data and the VM is still accessible. So we've just cordoned off and we've killed off that pod. And now we will go in, log in, go in and check in what the process is. You can see in the console on OpenShift, the VM the VM pod is going to move to another worker node. And when we do that, let's see if we can log in and ensure that we can, the VM is still intact. So you can see the process is just completing, and now we are going to log in into the VM, and we're going to again check if that same file exists, and that's pretty much which will verifies for us that the VM was able to be accessed from another worker node. So this demonstrates high availability. We also saw the live migration use case. These two are pause here and handle it on to Niranjan. Niranjan, can you take over?
Yes. Thanks, Prashant. Hey, good morning, good afternoon, everyone. I'm Niranjan. I'm from the Portworx product management team. So Prashant talked about a lot of capabilities that Portworx platform provides for VM applications. This includes high availability, disaster recovery, live migration, all the things that he demonstrated and sort of highlighted. What we're trying to do with Portworx really is give you a single data management platform that works for applications, irrespective of whether they're running on containers or they're running on VMs, and sort of lets you as a business owner, avoid the VM or VMware EL attacks that's becoming very common now, without losing out on any functionality. In fact, you gain a lot by getting your VM applications or current VM applications onto a containerized platform, because you basically not only modernize your infrastructure, but you get the flexibility and agility that containerized platforms now provide and have become ubiquitous. So in my section here, I'm going to talk a little bit about data protection and how easy it is to set up data protection for VM applications or applications running on anything on containers, really, whether it's running directly on a container or running on a VM on a container. What happens with the application world is applications running on container world is the data protection paradigm changes to become application centric. So you're no longer protecting only the data or only the volume or only the container for the application data. You're protecting the application in its entirety, which means you also get a lot of flexibility in how you protect an application. You get a lot of knobs and granularity of how an application is backed up, where it's backed up, where it's restored. Plus, you get all of the flexibility of being able to back up any application running on any container on any premise, whether it's on-prem or on cloud, and then moving it or restoring it to a completely different infrastructure stack. And all of that is possible for Kubevirt VMs as well. So how do you get started? It's as simple as setting up your Kubernetes cluster, your first set of Kubernetes cluster if you're new to it, deploying Portworx on it. Then Prashant talked about and actually demonstrated one of the migration tools that Red Hat offers. There are other CNCF tools as well. So it's really straightforward to discover VMs, your traditional vSphere VMs, migrate them to Kubevirt, and set up Portworx after that, set up the capabilities you need on Portworx, whether that's high availability, snapshots, and the size of your clusters, autopilot, auto scaling, all of the data management capabilities you need. And then you set up Portworx Backup, which is the backup and restore capability from Portworx. You add your Kubernetes clusters onto Portworx Backup, and then you start to enable data protection for these Kubevirt VMs. Now, once you do that, what happens with running Kubevirt VMs on Kubernetes and protecting them with Portworx Backup is the VMs and the applications on those VMs behave just like any other containerized application, right? So they can all live in the same cluster. They can all be protected by the same schedule, the same policy. You can use all of your modern Kubernetes data workflows. So if you're using Git pipelines for or also integrating your backup restore workflows. So that we have large customers who've sort of automated their backup and recovery of their applications into their existing Git pipelines, right? And that's the kind of flexibility that Kubernetes provides you, and that you can use with Kubevirt VMs as well, right? So the applications that are running on Kubevirt VMs, as well as get the full suite of granularity of deciding which Kubernetes resources are backed up as part of the application, what is not backed up, what needs to be modified at the point of restore, so that when you're restoring, you're restoring an entire application, and bringing up an entire application with just a few clicks, instead of having to restore a VM or restore its backend disk separately and then trying to recover your application from that state. So Kubevirt VM, in sort of a summary, is just another application or just another containerized application that we can protect with all of the bells and whistles of that Portworx Backup provides, including granular RBAC, custom RBAC, multi-cluster management, and simple one-click backup and restore. So what I'll do is show you a quick demo, right, of just how easy it is to set up and manage Kubevirt VMs, and answer any questions after that. So just give me a second while I start screen sharing. Right. So this is the Portworx Backup UI, the graphical user interface. Portworx Backup can be managed through UI, through API, through CLI, or integrated into your CI/CD Git pipelines. So what we've done here is basically it's sort of a demo to kind of give you an easy sense of how to set up and manage Kubevirt VMs. So here we have 3 sample clusters added. You can add and manage any number of clusters. We've basically have users managing even 100 plus clusters through a single dashboard. You go into one of those clusters, what you'll see is a dashboard of the applications that are in the cluster, that are running in the cluster, that are protected, the backup restore jobs that are running in the cluster, their activity timeline for the last 24 hours or 7 days, whatever timeline you want to see, some key alerts. As well, if there's something that requires your attention to take some action. And then you've got a applications tab that previously used to have just the namespaces or the applications listed for that cluster. So you still have that view in Portworx Backup. So what you're currently seeing is all of the different namespaces. These are sample namespaces, so you see the same name, but you could have any number of them. But now we also have a dedicated tab for virtual machines. So you could go click on a virtual machine, and then we would list all of the different virtual machines that are available in that cluster, the namespaces they belong to, and their status. So at this point, you don't need to be really conversant in Kubernetes and the different Kubernetes resources that are associated with a VM to be able to take a VM backup, right? So the whole goal here is to simplify without needing to get really into the nitty-gritty of their associated Kubernetes resources and what needs to be included and what does not need to be included. So at this point, you could select one or more VMs. So at this point, let's say I select all of the VMs. I can select all of the VMs in this page, or I can select all of the VMs in the entire cluster, and I can click backup. The default view is pretty simple, so it'll ask for just some basic details like your backup name, what's your backup location, where do you want to write it to. We support both object and NFS based backup locations, so you could back it up anywhere. You could use a schedule or back it up once. So the default behavior here is that we automatically include the write pre-post rules for VM crash consistency when you do a backup. So you don't have to worry about adding the right rules. You could, of course, go customize them. So if I click on custom rules, I can add my own pre-exec and post-exec rule. But by default, crash consistency is built into the system. We'll also list all of the VMs that are getting included in this particular backup, and then I go click on backup, and that basically is it, right? So it's really simple. Select a VM, select where you want to backup, set up a schedule or do it once, and then what this has done is really backed up multiple VMs and all of their required associated Kubernetes resources. So we take care of that in the backend, so you don't have to worry about it. Their PVCs, their secrets, the jobs, everything that's required for the VM to be restorable in any other cluster, in any other Kubernetes environment. So in the backup, you'll also see what's the size, which namespaces were included, the volumes, the resources. You can see this 71 resources, basically the Kubernetes resources. And then I can do a simple one-click restore as well. So I go click on restoring this VM job, this backup job. I'm sorry. You would also see all of the VMs. At this point, you could again unselect one or more of the VMs. So if you don't want to restore all the VMs, you could unselect that as well. So just provide a name for the restore. You can also do some additional steps. So the default assumes the storage class mapping stays the same, the namespace stays the same, but of course you could do some custom capabilities and change the storage classes if you want, right? So we'll auto detect the source storage class, and we'll also auto detect what storage classes are available in the destination cluster that you've chosen. Right, so then you can do a mapping. Once you do the mapping, you could also opt to either replace existing resources or let them be. If you are restoring to a running cluster with running VM, then if there's an existing resource, then we would not replace it if you uncheck this box. So you can go ahead and create restore, and then in the restores tab, you'll see that the restore is completed, and you'll see the size and details of it as well. So the whole idea is really, at no point in this workflow you would need to be a Kubernetes expert. You would just worry about what is the VM, what do you want to back up, and where do you want to restore it to, and everything that's all of the complexity of the infrastructure stack and the associated Kubernetes resources, all of that is hidden from you. You could, if you want to do a lot more granular and have a lot more granular control over each VM, you could still do that from the namespaces tab. In the namespace tab as well, you can still back up VMs, and there you will be able to individually choose each Kubernetes resource that you want to include in the backup, and select if you want that level of granularity. If you do not, then this gives you basically one-click backup and restore functionality. So that's that was sort of a overview and demo of how easy it is to protect Kubernetes applications and Kubevirt VMs that have applications running on Kubernetes. So with that, I'll hand over to Prashant for our roadmap and to give you an overview of what's coming in the near term, and look forward to questions.
Yeah, thanks, Niranjan. That's a great demo. What I wanted to discuss is what we have today to get you started with your Kubevirt based use cases. Then we'll talk about what's coming in the roadmap. So as we showed and demonstrated and covered in the demo, the basic use case around persistent storage, making sure that persistent storage for your Kubevirt volumes behaves the same way as it behaves for your rest of your environment. Along with that, we demonstrated VM live migration. We spoke about the use cases around that, DR, both sync and async, and Niranjan demonstrated backup. So backup had release, PX Backup 2.6, where we supported the backup and restore for Kubevirt and OpenShift virtualization. When I say Kubevirt and OpenShift virtualization, I just mean that anything which has a Kubevirt support will be supported, right? So OpenShift virtualization is where we've had our first set of customers already using this. So that's where our focus has been in making sure that we are completely integrated into that whole workflow with OpenShift. So that's available today. All of that is ready today. You can go in, use Portworx Enterprise 3.1 or PX Backup 2 should be able to use all of that functionality. In the upcoming next, I would say 3 to 6 months, what we are looking at is some improvements around performance based on some initial feedback, both for supporting single and multi-volume VMs. We've had both use cases, and now as more and more customers will adopt it, we do think there are areas where we can optimize and make that improvement better. Next is disk co-location. That's something which is required as part of the VM workflow. We'll be supporting that. Then finally, we are also doing auto detection for file-based granular VM backup and restore, and auto detection both for single click backup and restore. So this is all part of the backup release, which is going to be upcoming in the next quarter, and that's where we would be able to do and add these functionality. Long term, we are looking at, as we're talking to customers, what else is required in making sure that they are able to operationalize this in their environments. Storage vMotion has become one of the asks. We are starting to work on that, and we are planning to make that available in the second half of this year. Support for Harvester might come sooner. We are working with our partner there on Rancher. So Harvester is another platform where you can run VMs on Kubernetes using Rancher as the Kubernetes distribution. We are working with the engineering team there at Rancher just to make sure that all of the prerequisites are met, because the solution itself should be the same, but there may be some things we may have to do to integrate better. Auto-populating storage profile is another thing that will allow us to make sure we can make VM-specific optimizations in the storage profile for that particular volume. So these are all the things that we have been looking at in the roadmap. As we talk to more customers, I'm sure the long-term update list will grow, and that way we can add more. But this to us feels like a very pertinent use case where we can enable and operationalize running VMs and containers in a more efficient manner. With that, we'll pause for Q&A and take some questions.
Great. So everyone, please drop your questions in the Q&A box. We'll try to get to as many of them as we can today. And let's start with our first one. So what Kubernetes distributions are supported for running VMs on Portworx?
Yeah, as I said before, OpenShift virtualization uses Kubevirt, so that's where we've had our first integration. But anything which uses Kubevirt, any Kubernetes distribution that uses Kubevirt will be supported in this particular use case.
Great. And then we have another question here. How does Portworx handle multiple disks per VM that need to stay in sync during snapshots and DR replication?
Right. So if you look at it from a Portworx perspective, multiple disks are nothing but multiple volumes. So these are multiple shared v4 volumes. Portworx will handle the same way it will handle any shared v4 volume in its stack. So all snapshots, replication are synchronized. Everything is done based on schedules for snapshots. Replication is done based on how we use our intelligent scheduling mechanism within Portworx to make sure the replicas are available on the relevant nodes. We will group the volumes for particular belonging to the VM, and we'll make sure that they are all the operations are all synchronized, either doing a group snapshot or making sure the replicas are available from groups in the same node. So all of that is handled in the backend. We are doing some optimizations on performance, as I said, for multiple volumes in the roadmap.
Great, thanks. So we also have a couple of questions in the group chat, so I'm going to read a couple of those. So Prashant, I think this was a question based on your demo, that it was OpenShift based. How would this look for people using vSphere and not OpenShift?
Yes. So as I said, from a underlying engine perspective, if you're using, when you say vSphere, if you're using Tanzu or other Kubernetes distribution, if it supports Kubevirt, there is not much change. You will still have to do the migration or bring in those VMs on that Tanzu environment. But at that point, Portworx shared v4 volumes will be the way to go. You'll just have to make sure you use the right storage class with Portworx, and the rest of it will function the same. We don't have integration in terms of the UI console like we have with OpenShift right now. But that's something that we've been working with the Tanzu team broadly outside of Kubernetes, or outside of this VM use case as well. But purely from a VM deployment perspective, it should not be any different.
Okay, and then I'm going to bounce back and forth between the group chat and the Q&A, just so we're covering people's questions. But how do we back up data in case we delete something manually or accidentally?
Yeah, I can take that. So once you have backed up a VM, right? So depending on the schedule, even if you delete VM manually or accidentally, you'll be able to restore the entire VM and the application running in the VM based on whatever your last available backup, last taken backup was. In fact, in the near term, you'll be able to restore a file or a specific set of files in the VM rather than the whole VM as well. So once you have at least one backup available, that's precisely what you're protecting against, accidental deletes or inadvertent deletes. So.
Okay, and we have another backup question here. Does Portworx support backup and restore of VMs across clouds and regions?
Yes, it does. So in the spirit of the agility and flexibility that containers provide, right? So Portworx Backup supports backup and restoring across premises, across clouds, across regions, across distributions. So we have no limitation in terms of what the infrastructure stack you're running is.
Okay, excellent. Thank you. What is the impact of upgrades and changes to Portworx to our existing infrastructure and workloads?
So this is generically for any upgrades to Portworx. This doesn't necessarily mean any different VM situation, but the impact of upgrades is depending upon what upgrade it is. Like if it's an OS upgrade on a node, that's just the node upgrade. Portworx, will, because it's a distributed thing, the replicas will be moved around. The node will go into maintenance mode, and you can upgrade the node. But all the other upgrades for Kubernetes distros and even Portworx are rolling upgrades. So Portworx handles that. Like we have been doing upgrades for all of the customer environments even before, for a regular container-based applications as well. So these are all zero disruption upgrades, and we are working on ways to do multiple node upgrades at the same time. We're making some changes to the pod disruption budgets in order to allow us to do that. But from an upgrade perspective, these should be all non-disruptive upgrades.
Okay, and then another question in the Q&A, what are the additional requirements for Metro Sync and regional async DR setup? What software is being used for S3 and what additional environments are needed for a true DR setup? Sorry.
Great. So I'll break this out into a couple. There are additional requirements. They are in the documentation around both for sync and async DR. We do require a witness node to be running today in a third data center, hopefully, and that will allow you to create a independent sort of failover mechanism where you can switch from source to destination. The requisites for witness node can be running on a VM. It doesn't need to be running on a Kubernetes cluster, but we are also trying to simplify that and optimize that in upcoming in the roadmap around how the witness node we can remove the requirement for a witness node somehow. So we're working on that. The second part is resource requirements are all in the docs, but from a true DR setup perspective, it's basically depending upon whether you're running sync DR, you will need it's just a single Portworx cluster stretch. So cluster domains are automatically handled by Portworx, and the witness DR will do the failover. If you're doing async DR, there are requirements. In sync DR, there are requirements around latency where you can stretch the cluster. So we ask for less than 10 millisecond latency between those two data centers. Async DR is across two cloud regions, and that's something which will work because it's snapshot based. There is no requirement around latency there.
Great, thanks. And then bouncing back to the group chat. So I see in the backup docs that it requires I'm going to butcher this, QEMU guest agent, which is difficult to install on appliance-based VMs and only works on single interface VMs. I'm not sure what the question is, but Niranjan, do you want to address that?
Yeah. So yes. So Kubevirt VM, it's sort of based on KVM. So it requires a QEMU guest agent on the VMs to to work and to take snapshots. That is, a requirement of the infrastructure layer that Kubernetes provides itself. And on the second question on it works on single interface VMs, that is for the current release, we are planning to support multi-interface VMs on the roadmap. So that's a work in progress.
Okay, and then we have one more question in the group chat. And if you have any others, feel free to drop them in. So have issues been fixed around NFS mounts for PVs serving VM disks? For PVs serving VM disks getting disrupted by node failures?
Yes, there were some bugs found as part of the initial. They were all resolved in 3.1. We are making some changes in the way we are doing KubeVirt hyperconversions. That should be coming, as I said, in the next 3 months. That's one of the things in the where we would allow us to handle the mounts within NFS. We are making changes to make sure that when there is a controlled node maintenance period or controlled upgrade event happening or something where the node is going to go offline, we will make sure that live migration and everything else around NFS mounts that can disrupt the mount points can be handled more gracefully. So the changes for some initial bugs have been fixed already in 3.1. More optimizations are coming in the upcoming release that will smoothen this workflow even more.
Great. Thank you, everybody. I believe that wraps up everyone's questions. So we're going to wrap it for today. Thank you for joining us and engaging us with questions. I do want to remind everybody that we will send a recording of this webinar to everybody who's attended, and you'll also get a little bit more information if you want to learn more about anything we've talked about today. Please feel free to visit our website if you have any more questions or would like to engage with us further. And once again, thank you all so much for joining us today. With that, I will conclude today's webinar. Bye, everybody.
Thank you.